So, problem number 8, it says SnO2 form both positively and negatively charged colloidal solution in acidic and basic medium. Explain this phenomenon. So, SnO2 is amphoteric. Okay. So, SnO2 is amphoteric in nature. So, it reacts with both acids and bases, right? So, it reacts with both acids and bases. If it reacts with acid HCl, it forms SnCl4 in solution. The common SN4 plus ions are adsorbed on the surface of SnO2 to form positively charged sol. Positively charged sol. The reaction can be written as SnO2 plus 4HCl gives SnCl4 plus 2H2O. Now, we have the SnCl4 which forms Sn2 plus ion. So, Sn4 plus ion. So, you get SnO2 plus Sn4 plus gives SnO2 Sn4 plus. This is positive sol, right? Positive sol. Now, when SnO2 is amphoteric, so it reacts with both acids and bases. We discussed with for acids when it reacts with acid HCl. Now we discuss with when it reacts with base, okay, NaOH suppose, okay. If it reacts with base NaOH, forms, okay, so gives or produces sodium stannate. The formula of sodium stannate is Na2SnO3. So, sodium stannate in solution. The stannate ion ions are adsorbed on the surface of SnO2 like before. So, when it reacts with acid HCl, it forms SnCl4, which forms Sn4 plus ion. Now, Sn4 plus ion got absorbed or is getting adsorbed on SnO2 surface, so form positive sol. And here when it reacts with SnO2 reacts with NaOH, it produces sodium stannate in solution. So, the stannate ions now are adsorbed on the surface of SnO2. So, we get negative sol here, right? Okay, or negatively charged sols SnO2 to produce negatively charged sol. Okay, the reaction can be written as the corresponding reaction we can write reactions here. So, corresponding reactions can be written as so SnO2 plus NaOH gives Na2 SnO3, so 2 NaOH we will require probably, so H2O. Now SnO2, the standard ion is SnO3 2 minus, this is the standard ion. So to form SnO2, then SnO3 2 minus, so we get negative sol here. Next we discuss problem number 9. It says on passing H2S on an aqueous solution of SO2, a yellow turbidity is formed. Explain. So on passing H2S on an aqueous solution of SO2. So here oxidation takes place. Okay, we did discuss in the class. Okay, oxidation of H2S occurs. Okay. The reaction is, or the reaction can be represented as 2H2S plus SO2 gives 3S plus 2H2O, right. So here S is minus 2 oxidation state, here it is 0, so this oxidation takes place here. Okay, so this is, so this 3S is like nothing but is colloid. Okay, S is colloid here. So the precipitates, the particles of sulfur, gets condensed to be in the colloidal range. Therefore, a turbid solution containing colloidal particles of sulfur is formed. Next we discuss problem number 10. It says on an water insoluble substance of density 0.6 gram per centimeter cube is dispersed in 1.8 liter of water to form a solution having 10 to the 18 spherical particles per nanometer cube, per millimeter cube. Okay. If 2.4 gram of that substance is dispersed, then calculate the radius of the particle. Okay. So given 1 millimeter cube of sol contains how many particles? 10 to the 18 spherical particles. Particles are spherical particles. Okay. So 1 centimeter cube of, therefore the 1 centimeter cube of salt contains, so 10 to the 18 times 10 to the 3, right? If we convert meter cube, millimeter cube to centimeter cube, we get 10 to the 3 factor here. Okay, so we get 10 to the 21, 10 raised to the 21 spherical particles. Why we need to convert to millimeter cube to centimeter cube? Because the density is given gram per centimeter cube here. Okay. So again the mass of, the mass of the dispersed substance, again the mass of the dispersed substance is 2.4 gram and density is 0.6 gram centimeter raised to the minus 3. Okay. So volume of dispersed substance, then we can calculate volume from mass and density. Therefore the volume of the dispersed substance is 2.4 by 0.6 centimeter cube. Okay. So if we calculate this, we get 4 centimeter cube. So this is the volume of the dispersed substance. Okay. And how many particles we have? We consider that one, that particles. Okay. So how many? What is the volume of volume of a single particle? Okay. Because we need to calculate the radius of the particles. Okay. So we need to calculate the volume of a single particle or one particle. Therefore, the volume of one particle. So how many particles are there? 10 to the 21 spherical particles are there in volume 4 centimeter cube, right? Okay. So and again it is in 1.8 liter of water. Okay. So we get 4 by 1.8 times 10 to the 24 centimeter cube. This is the volume of a single particle. Okay. Right. So how it is coming? So 1.8 liter means 1.8 liter means 1.8 times 10 to the 3 centimeter cube, right? And so 1 centimeter cube of salt contains 10 to the 21 particles. So therefore we can write here actually. So this is just, I wrote it in one line. So 1 centimeter cube contains how many particles? 10 to the 18 particles. Sorry, 10 to the 21 now. 1 centimeter cube contains 10 to the 21 particles. And how many? What is the volume now? Volume is 1.8 times 10 to the 3 centimeter cube contains is 1.8 times 10 to the 3 times 10 to the 21. So we get 1.8 times 10 to the 24 particles. Okay. So that's what this factor comes here, 1.8 times 10 to the 24. Anyway, so this is the total number of particles and this is the volume 4. Okay, so this is the volume of one particle. Now particles are spherical in nature. The particles are spherical in nature. but spherical. And let us consider the radius of the particle is r centimeter. Therefore, 4 by 3 is the volume of a particle. So, okay, the volume of a single particle. Therefore, the volume of a single particle or volume of one particle is 4 by 3 pi r to the 3 centimeter cube. So, we can equate now 4 by 3 pi r cube equals to 4 by 1.8 times 10 to the 24 centimeter cube. Therefore, we can write 4 by 3 pi r raised to the 3 is 4 by 1.8 times 10 to the 24. So, r cube will give you 3 by 1.8 times 10 to the 24 times pi. Okay. So, if you calculate this one, we get r is 8.1 times 10 to the minus 9 centimeter. Okay. So, therefore, the radius of the particle is 8.1 times 10 to the minus 9, 10 raised to the minus 9 centimeter. Next, we move to problem number 11. It says, blue color of water in sea is due to refraction of blue light by impurities in sea water, scattering of light by water, refraction of blue sky by water, none of this. So, correct option, you know, this is very simple thing. Okay, correct option is A. Correct option is A here. Problem number 12 is which type of property is Brownian movement of colloidal salt? Electrical, optical, mechanical or colligative? Okay, colligative cannot be, optical also cannot be. Okay, it can be either electrical or mechanical, but in this case it is mechanical, right? Because we calculated pressure and everything there. Okay, so C, the correct option is C here. Problem number 13 says, a spherical particle of radius 1.2 micrometer and density 2.8 gram per centimeter cube falls in water at 23 degrees Celsius. Density is 1 gram per centimeter cube and dynamic velocity is 1.002 times 10 to the minus 3 Pascal second. Calculate the terminal settling velocity using Stokes law. How long will it take to settle 10 centimeter? So, we know terminal settling velocity is, if we say Vt is 2 by 9, we already discussed in the class, Rs raised to the 2 rho 2 minus rho 1 times G by eta, right? Okay, eta is the viscosity. Okay, so here Rs is 1.2 micrometer, right? So we can convert into meter. So 1.2 times 10 to the minus 6. So we will all use here in SI unit. So Rs is 1.2 micrometer, it says, yeah, 1.2 spherical particle of radius 1.2 micrometer. So we can convert into meter. So we get 1.2 times 10 to the minus 6 meter Rs. Rho 2 is 2.8 gram centimeter to the minus 3. So we can convert it into SI unit again. So 2800 kg meter raised to the minus 3. You see the density is given 2.8, right? Falls in water at 23 degrees Celsius, density, okay, rho 1 is given, rho 1 is 1 gram centimeter raised to the minus 3. Again we convert into SI unit, so 1000 kg meter to the minus 3. G acceleration due to gravity, so we know 9.8 meter second raised to the minus 2. Okay. And what else is given? Eta is given. So eta viscosity is given 1.002 times 10 to the minus 3 Pascal second. So again we convert into SI unit, 1.002 times 10 to the minus 3. Okay, so kg meter to the minus 1 is to the minus 2 s. So now we put all these value and we calculate Vt. So Vt will be 2 by 9 times 1.2 times 10 to the minus 6 whole to the 2, and then density rho 2 minus rho 1, 2800 minus 1000, right? And then G is 9.8, and then eta is 1.002 times 10 to the minus 3. So if we calculate this, we get 5.63 times 10 raised to the minus 6 meter per second. So first part is done. Okay, so terminal velocity. Okay, so Vt. Okay, therefore the terminal velocity Vt is 5.63 times 10 raised to the minus 6 meter second inverse. Now second part, how long will it take to settle 10 centimeter? Okay, so this many distance goes in 1 second, right? Okay, this many meter. Okay, so 5.63 times 10 to the minus 6 meter distance is covered in 1 second, right? And 10 centimeter is 0.1 meter, right? Therefore 0.1 meter distance is covered in 1 by 5.63 times 10 to the minus 6 times 0.1. So if we calculate this one, we get 2, or first we can calculate it in second. Second is 17761.762 we can write second, or we can write 296 minute roughly. So we get 296 minute.